Thanks for showing up this morning. I know it's kind of early, 8 o'clock. I'll try not to put you all back to sleep, but welcome to the challenges and opportunities of gas flow measurement and ventilator testing, which is a long-winded way of saying we're going to just talk about some of the things that you might find challenging in the field and maybe give you some solutions. Or up. Okay. There we go. I get. Okay. All right. I'm Kerwin and I've been in the industry. I've actually been working for IMT.Analytics for about 8 years now as their business development director. But I've been in the industry for over 30 years. I started out with a company called Puritan Bennett. I don't know if anybody's familiar with that, which became a bunch of other companies over the years. And then I worked with Respironics, who became Philips, and just a bunch of different ventilator companies. And most of that time I spent teaching people how to service ventilators. So I've had a lot of real life experience using this type of equipment that we're making now. It wants me to stand over here. There. Okay. So just a quick poll, just to get a little more involvement. Who's currently working on vents and anesthesia machines? Either one. Pretty much everybody? Anybody that's never worked on one? Okay, so you're new to this? Okay, great. Well, we'll try and keep it interesting for people who are very experienced and then also for people who are not. So we're going to try and cover a lot of different topics, but mostly they can be applied to any ventilator, any anesthesia machine, and really any analyzer. I have examples here that are kind of, they're actually real examples, so they'll have people's ventilators and different analyzers in them. But we're really kind of talk about things in general. So if you have an analyzer that we don't show up here, things should still apply pretty much, okay? Since I have been working for IMT, I've really been focused on the test equipment side. Before I was trying to teach ventilation a lot and a lot of the service topics there. But now we're really focused on analyzers. So full disclosure, our company does make analyzers. And so and we think they're very good, but you can come by the booth later and see them. But I've, through this experience, learned a lot of the problems and the things people are seeing out there in the field. And if any of this sounds familiar, let me know. Feel free to join in and ask questions as we move along too. And don't hesitate. The more interaction I have, the better. So let's talk about the challenges. Jump right into this. We're going to talk about 3 of them today. And I know there's probably a whole lot more, but these are kind of general and hopefully they apply to most situations. The first one that we see a lot of are complex and unclear measurement setups. And by that I mean, what is the manufacturer of the product that you're testing told you about how to test it? 2, I see a lot of problems with people who have analyzers and maybe don't know all the features or exactly how to set them up. So we'll talk about ensuring that you have the proper setup on your analyzer for your applications. Okay. And 3rd, understanding the actual test sequence and valid ranges, because a lot of times manufacturers are not the clearest. They don't give you the best way to find what the actual valid range is of any certain measurement. And we'll get into that in detail later. Any questions about any of this? We're doing okay so far? Okay. All right, let's talk first about these complex and unclear measurement setups, and we'll show you some examples that we see. Here's one from a manufacturer, and they actually went kind of a long ways down the road of showing you how to set up an analyzer on their ventilator. They did a pretty good job. They have a lot of pictures. Um, the problem is not all the things are very clear there. Like, for example, you might not see that there's pressure that has to be teed in right here. Okay. On their other screen here, you might see that the oxygen sensor has been put in place. Okay. So there are some things that are still missing here. And the biggest problem with this is they've shown you one analyzer. They chose this analyzer because it was popular at the time, and so they put it in their service manual. And if you don't have this analyzer, now you have to kind of figure out, how do I substitute my analyzer for this one? Okay. Here's another example from another manufacturer, and they show a different analyzer and of course a different ventilator, and they're not real clear. They didn't spend a lot of time on showing you how to hook this thing up. You can't see exactly where to hook it up to the ventilator or the analyzer. And I know for a fact, because that's our analyzer, I think, that the test lung should be attached to the back, okay? Because everything goes through this main flow channel. So a lot of times, again, they're not 100% clear on how to set up your analyzer. It gets worse. This thing has a very limited range. Here we go. I'll just stay over here. In this example, they just tell you to tee in a flow/volume analyzer, and then make sure that VTI is displayed on the analyzer. It's like, wow, that's so vague, So there's a lot of vagueness in what manufacturers have put out there for you. And so those are real challenges. And so let's talk about maybe some simple opportunities that you can have to overcome those challenges. First and foremost is understanding your gas flow analyzer, no matter whose brand it is. I think I've used them all at one point or another. And I can't say, bad things about any of them. For the most part, all the analyzers out there, Flukes, TSIs, IMTs, a few others, they all work. They all measure flows, they all measure pressures, they all do it a little bit different. And so whatever one you happen to have, the best thing that you can do is really get to know that analyzer, know what its features are, and then how to apply them to the ventilators that you're testing. Now, you can get a lot of that information directly from the manufacturer of the analyzer. Ours, for example, we have a lot of YouTube channels and things like that to our videos on our YouTube channel, so that you can see how we're actually applying our analyzer to different products. And on the other side, you have to go with the manufacturers of the ventilators or the anesthesia machines and see how they say to test it. A lot of times their manuals, as we saw, are not real clear. So depending upon which analyzer you're using, your setups can look very different. Okay, the one that we said earlier, this of course is one setup. There's an analyzer here, and it's got a flow module, it's got a pressure T, it's got an oxygen T, a lot of different connections there, and then of course it's got the display module. A fairly complex setup, but it works, right? But there are other options. Some of the devices like ours, they're all-in-ones, and the setups could be as simple as this. Patient circuit on one side, test lung on the other, possibly a proximal patient pressure tap, and that's it. So depending on which analyzer you have, your setups might be very different, even though they're all measuring the same thing. Okay. The other thing is, if you have the chance, of course, is to select an analyzer that simplifies your setups. One like this one, where the patient circuit is on one side, the test lung is on the other, and almost all the parameters that you could possibly need for testing that ventilator are measured through one flow channel. No need to tie anything else in, no need to have a different module for different flows. These are often called all-in-one devices, and this is just one example. There's others out there. But that's what a lot of the newer ones are going to. A single channel to do almost all of your measurements. Okay. And what that does, of course, is help to minimize errors that are caused by setups that might be done incorrectly. Any questions so far? You doing okay? Everybody's nodding, but don't know if that's falling asleep or. Okay. So challenge number 2, of course, is making sure that our analyzer is set up correctly. Okay. And here's where we start getting into a little more technical stuff. But we have to make sure we're using the right gas type, the right gas standard. Those are all used for flow measurements and volume measurements. Trigger settings, so that we can trigger on the breaths that we're trying to measure. And not only the volume, but trigger also affects things like PEEP, rate, of course, tidal volumes, IE ratios, all the different timings that are found from knowing when inspiration starts and exhalation starts. Okay. And then, of course, the measurement parameters themselves. We'll see, and we'll talk a little bit more about it later, but a lot of manufacturers call things something different than you might see on your analyzer. For example, peak inspiratory pressure. Some people call that PIP, P-I-P. Some people call it P-peak. There's a few other names like that, right? Same way with even something simple like rate. Some people call it, or some ventilator manufacturers call it frequency or breaths per minute, okay? So sometimes you have to do a little bit of interpretation on the measurements themselves to make sure you're measuring what they want you to measure. And then, of course, you also have to make sure you're using the same unit of measure. Some manufacturers like centimeters of water. Is it centimeters or sonometers over here? Which one is it? Okay. East Coast, we're not far enough east yet, right? If you go the further east you go, the more sonometers it turns into instead of centimeters. Potato, potato, right? Anyway, and some people use hectopascals and some people use millibar. So it all depends on the ventilator manufacturer. So just make sure that you're comparing apples to apples all the time. Okay. Let's talk a little bit more in depth about the gas type and gas standard and why it's important and what they are. Is everybody familiar with different gas standards? How about gas types? Okay. Well, those two things really are characteristics or conditions of gases, right? So let's say we capture a little bit of room air in a container with a movable lid, right? And it's going to be mostly nitrogen and about 21% oxygen, maybe some trace gases, but pretty close. 20.8% oxygen, who knows? But if we change the condition of the gas by increasing temperature, what happens to the volume? It goes up, right? It increases. And it doesn't just increase, it increases at a linear rate based on temperature. So we know that for every rise in temperature, degree of rise in temperature, that we might see a percentage of volume increase, right? Same way if we add humidity to this same gas, right? We start to take up more volume, right? So again, percentage of humidity, we know that it changes the volume by a certain amount, right? If we put that same gas under pressure, we can actually reduce its volume, okay? So those are all conditions. And then, of course, if we change the oxygen concentration, now we change the gas characteristic a little bit, right? and it can actually increase volumes as well. So all these things, the characteristics and the conditions of gas, change the volume that we're measuring, okay? Why is that so important, right? We have the same number of molecules in here, they just take up more room. Well, when they get into the patient, right, we want to make sure that we're putting the correct volume in their lungs, right? So it's not too small and not too big. And so we want to be able to make sure that we can control that. We'll get a little more in the weeds here. Gas density, viscosity, and viscosity coefficients are all gas type setting. Okay, those all change based on how much oxygen you're using. In rare conditions, you might have heliox or something more exotic, but almost all the time you're going to be measuring air and some level of oxygen, okay? But those change based on that. You may have to tell your analyzer what you're measuring. Is it air only? Is it oxygen only? Is it some combination? Some analyzers can tell you that automatically because they have O2 sensors built in. But you may have to make sure that your gas type matches what you're actually trying to measure. The other things like differential pressure, gas pressure itself actually, temperature, humidity, and again, oxygen concentration, those are all typically measured by the device. Okay, you don't have to go in and set that. You might, on some, you might have to tell it how much oxygen's there, as I said before, for gas type. You might have to say, oh, it's 100%. And in some cases, you might have an analyzer where your O2 sensor isn't working. You can still use the analyzer, you just have to tell it how much oxygen you're testing or how much air or what combination it is. But the gas flow analyzer takes all these into account and calculates a flow, okay? Not really a volume yet, but a flow. And we call that gas measurement, right? Oops, okay. So whenever we measure with an analyzer, we're actually measuring whatever the gas is currently, right? We know it's the atmospheric actual temperature and pressure. Oh yeah, I can't walk over here, I forgot about that. It's over here, yeah. Yeah. It's a little dongle thing, so it's okay. Anyway, so when we measure the flow, it's in ATP. It's because we're actually measuring what it happens to be right when we're measuring it. No matter where we measure it, if we measure it inside the ventilator or if we measure it with an analyzer, okay? And we can then convert that to other gas standards if we want to, okay? How many people have heard of other gas standards, things like STP, BTPS, AP21, things like that, right? So all a gas standard is doing is adding an offset value to your ATP measurement based on the conditions of that gas, okay? Because we know sometimes it's going to be dry and it's going to be room temperature, and other times we'll see that it's going to be maybe humidified. Sometimes it will be room temperature, maybe, or colder, coming from devices that use wall air systems or oxygen bottles. If you have a blower-based device, that naturally heats up the gas, right? So whatever we're getting from the device we're trying to measure is ATP, but we might want to display it in another gas standard. So we can convert that and use our whatever gas standard we choose, and then we can display that, okay? How's that important to us? In real life, when an operator uses a ventilator, in this case an ICU type vent, critical care, they typically will have it attached to the patient, and it will be on a circuit that has a humidifier in it, okay? And so if they pick maybe half a liter of gas or something, some similar, that ventilator is going to put that measurement out there, right? It's going to say, okay, deliver 500 mils. And as that goes through the patient circuit, it's going to pick up humidity and it's going to get warmer. And so by the time it gets to the patient, it's no longer ATP, right? Now it's at about 100% relative humidity. It should be at body temperature. And so the volume is going to increase, right? And so some ventilator manufacturers take that into account, and their ventilators display in something called BTPS, right? So on the screen, what you would see for your setting and for your measurement from the ventilator would be something more like 560 mils. The ventilator itself is really putting out 500, but by the time it gets to the patient, it is the BTPS standard now. Make sense? Does everybody understand that? And again, it's just an offset and a convenience factor for the operator of the ventilator, because now they don't have to guess. If they say, okay, I want to send 560 to my patient, they don't have to reduce it themselves down to 500. The ventilator does it for them. So it automatically compensates, knowing that it's going to be heated and humidified. Now, not all ventilators use a heater or humidifier. Okay, in this example, we're using a ventilator that displays the values in BTPS. We may have other ventilators out there that just use like a artificial nose or a single limb circuit, maybe a mask, things like that. Those may just display it in either ATP or STP, okay? Or any of the other 17 or so gas standards. There's a lot of them out there. So what happens when we test the ventilator? Do we have a humidifier in line? If we do, it's not turned on and it's not full of water, right? It's only in there for volume of the circuit. So when our ventilator setting is saying 560, the ventilator is still putting out 500, so that's what we measure. So this looks like a big problem. And it will happen across the board. You'll see it on all different volume settings. You'll be about 10, a little more than 10% off. And that's a real easy way to see if you have a mismatch between your gas standard and the ventilator's gas standard. If it happens at all the settings, then you know it's a problem with the gas standards. If it happens at only one, it's probably some other problem. Does that make sense? So the little troubleshooting aid there. First thing I do when people say, oh, my volumes are off. I say, how much are they off from? And they say, oh, about, 60 mils, 50 mils at half a liter. And I said, well, do it at 100 mils and then do it at 800 mils and tell me again, how much are they off? Oh, they're off about the same percentage at both of those. I said, okay, what gas standard is the ventilator displaying? And that's when people go, well, I don't know, because it's not usually printed on the ventilator anywhere. You have to dig in sometimes and really go into the manual of the ventilator to find out what gas standard they display. Okay, so when we have that 560 actually displayed there, we know that it's going to be 500 at ATP, or 21 degrees C, which is room temperature, and hardly any humidity. We don't change the gas. We get it to our device. It's still 500, but we're going to measure that 500. And if we set our gas standard to BTPS, then it's going to show that we have 560. So the important thing with gas standards and gas types are what? Make sure they match, right? Make sure you're comparing apples to apples. Right? Again, in your calibration setup, you've got 560, delivered is 500. We're measuring that 500, we're displaying 560, and we're happy. Make sense? Any questions? Okay. Really? Yeah.
You don't think about it.
Yeah.
You catch yourself, 20 years ago.
Mm-hmm.
You're just like, okay, just going down that rabbit hole. What the hell's going on? And,
yeah. Why am I off everywhere? Why these volumes?
Figure it out, and so it just clicks, and oh yeah, that's right.
Well, the first thing I think of is, oh, the ventilator's not functioning properly.
We
you
all
know.
about that.
You know.
Then we figured it out.
And I might, switch on just the air side and see what happens, or just switch to the oxygen side and see if it's still doing the same thing. And then, then I get two different readings now because one was air and one was just pure oxygen. And now the volumes are still not quite right, but they're different. And you start thinking, oh, I need to replace some flow sensors in my ventilator. Okay. Until, like you said, then it clicks, and you're like, wait a minute.
The full parts store, and then we go grab another ventilator, and okay, it's the same problem.
Yeah, then you grab it. Yeah. So yeah, keep that in mind. I always have like 5 different things I tell people when they're troubleshooting. It's like, is your analyzer warmed up? Did you zero it out? Have you set the gas type and the gas standard correctly? That takes care of like 90% of the problems. Because as soon as they go through those things, they go like, hey, oh, wow. What did I say? 5? Warmed up, zeroed out, gas type and gas standard. Oh, and the next thing, trigger values. Trigger values. Thank you. Good segue. Perfect timing. Glad you're listening. So the next setting that's very important is our trigger values. And we'll go through a little bit about the background behind triggering. Is everybody familiar with this? Have you ever had any problems with it? Let's talk a little bit more about it. So we want to be able to tell our analyzer if we're in an inspiratory phase or an expiratory phase from the ventilator or anesthesia machine. It's a ventilator in an anesthesia machine, right? So that we have accurate volume measurements and accurate breath timing measurements. Okay. Again, VTI, VTE, rate, IE ratios, PEEP values, all those things depend on us knowing when we're in inspiration and when we're in exhalation. Okay. By the way, trigger settings on your analyzer have nothing to do with trigger settings on your ventilator. Has anybody heard those two terms? Trigger settings on your ventilator are really a sensitivity setting, so the ventilator can tell when the patient wants to take a breath. Okay. Trigger settings on your analyzer, completely different. It's how does the analyzer know which breath phase we're in? And it seems like, oh, it should know, right? But we'll see some examples why it might not, or might not quite know. Okay, so here's a quick example. What we're trying to do, if we measure VTE or VTI, we're measuring the area under the curve, and we're integrating that to get the total volume. So we're measuring flow over time under that curve. And if our trigger settings are off just a little bit, you see here where we're starting a little bit late and we're ending a little bit late. Well, we've missed some of the volume, so now this value is going to be lower. We've added some negative volume, so this is going to be even lower again. So now our tidal volume, the ventilator's telling us we have 560 or 500, whatever, we'll just use 500. And now we're looking at something less than 500. And we're saying, well, how can that happen? Why am I measuring less? Well, it's because you may not be triggering soon enough or on a clean signal. Okay. So trigger depends on really 3 things. What trigger source you're using. We can use pressure, we can use flow. In some cases, we have a digital trigger signal coming from the ventilator. Right now, we'll just talk more about the pressure and flow, because digital just tells it straight out, I'm in inspiration, I'm in exhalation. It's a TTL signal that comes off some ventilators. Have you ever tested a V60 ventilator? You have to use a trigger cable, right? The only reason you have to use a trigger cable is because the analyzer doesn't know the difference between inspiratory and expiratory on that ventilator. If you used a different analyzer, you could set the trigger settings so it would know. We'll see that in a moment. All right, so trigger signal then is defined by which signal, right? And then what level. Okay. Let's take a look at some example waveforms. In this one, is this a good trigger signal? What do you think? No, why not? Good, very good. So we see here that we have a pretty good rising edge to tell us I'm entering inspiration, but on our trailing edge here at the end of inspiration, it drops below a value and then just kind of trails off, and we don't have a very clean end of inspiration signal. So what we're trying to do is match the real inspiration phase to our triggered or analyzed phase. And what's happening here is, notice that the real inspiration phase is much longer than the actual one. So this is a good start to our trigger, for our trigger value, but here it doesn't really end well, right? We don't have a nice sharp signal to test. So here's another one that looks maybe better or worse? Better, right? Because we're looking for those, the quick rise times or quick fall times, right? We want to have a nice clean indication or signal of inspiratory versus expiratory phase. And for the most part, this is pretty good. However, it is a little shifted in time, right? Because we want to set our trigger settings just a little bit outside of the noise range. Sorry, this gray band would be where it's kind of noisy. So we want to start the trigger here, and then we're ending a little bit late. So you see the phase is about the same size, but it's just shifted a little bit. So that might slightly affect our timing. But it's still pretty good. It's still a pretty decent signal. If we find a signal that looks like this one, what do you think then? Good or bad? Who says good? Who says bad? Who's non-committal? All right. This is actually a very good signal, okay? Because what we can do here is we can say, set our trigger level here, and we have a nice sharp rise. We can measure that entire phase, and we don't start to declare exhalation until this point right here. So our real inspiratory phase is almost exactly the same as our analyzer measured phase. So even though it looks like a very square wave and it goes to zero for a little while, it never drops below zero until it starts the exhalation phase. So it's actually a good signal. Okay, and that's what we want. Again, we want that sharp rise, sharp fall. So a good signal has both those. In most adult ventilators, you can have pressure controlled ventilation or you can have flow controlled ventilation. But no matter what the ventilator setting is, and there's combinations of those now on some new vents, but you can almost always have a nice flow signal. So even if they're doing pressure ventilation, the flow signal is usually the best one to trigger on. So your analyzer should let you pick pressure or flow. Some don't, some only give you flow. And we'll see where that might be a problem later. But for the most part, flow is the best signal to do. So we, in this case, we'll measure our trigger source through the flow channel. The flow signal itself would be the one of the two that we want to pick instead of pressure. We want flow. And then the trigger levels we would set at about +3 liters per minute and about -3 liters per minute. And then we get pretty much the entire inspiratory phase, and we know when exhalation starts. The good news here is most analyzers have settings that are very similar to this as their default. And some analyzers out there have different defaults for pediatrics and high frequency as well. So for about 90% of the time, if you set the default values, they're fine. It's only when you start to have noisy signals or you have some kind of, if you have surprisingly, what really affects a lot of times your triggering when you're doing testing is how good is your test lung. It's true, because your test lung will be, if it's bouncy, you know, if it's very loose, if you got a test lung that looks like a worn out balloon, you know, the band is gone off of it and stuff like that, you're gonna get some terrible signals. And it's not the ventilator's fault, it's trying, it's just that your test lung is not doing a very good job, right? So you'll have noisy signals, and when you do, a lot of times you can look and see what that waveform looks like, and then you can adjust your trigger values to take care of that until you can get a new test lung, right? So we do have default triggers, and they take care of most things. There is another challenge, however, when we start to talk about BiPAP units. Is everybody familiar with the term BiPAP? What's it mean? Somebody tell me. Positive airway pressure, right? Bi meaning two, right? So two positive airway pressures. One higher during inspiration, one lower but still positive during exhalation. Okay, what kind of signals that can give us to trigger off of? Right? So are we gonna see a exhalation from this? We don't, right? Because the gas isn't coming back through the ventilator or then not going back through the analyzer on its way to the ventilator, the analyzer will never see the exhalation phase. And this is why when you test a V60, that's a BiPAP unit, you have to have a trigger cable, okay? Because it has to tell the analyzer, I'm in inspiration, I'm in IPAP, and I'm in EPAP. IPAP, inspiratory positive airway, EPAP, exhalation positive, right? So if we don't have a cable or we don't have an output for the trigger signal, and we're on a BiPAP unit, because there's a lot of them out there besides the V60, what do? You can go to pressure triggering. And that works fine because we still have a nice square pressure waveform, right? It starts out and rises above the EPAP level. So we just have to set our threshold somewhere above the EPAP level, a little bit, right? So as soon as we go from EPAP to IPAP, we start to measure the inspiratory volume. And then as soon as we drop a little bit below IPAP, we set our trigger point there. Now we capture the inhalation phase, no problem. We can still tell what VTI is. We can never tell what VTE is because it just goes out to atmosphere. But in most cases, when you're testing a BiPAP ventilator, they won't ever ask because they know it's not coming back, right? Their ventilator isn't trying to measure exhale tidal volumes like an IC vent. So that works pretty well. Let's take a quick example. Let's say I have an IPAP of 6 and an EPAP of 2. So I set my trigger signal at 3 centimeters, which is just 1 centimeter above my EPAP. I set my my stop trigger at about 5 centimeters, which is just one below IPAP. And it gives me a nice signal, right? I can capture pretty much all the inspiratory time. And so now my analyzer works fine measuring a BiPAP unit. But of course, the ventilator manufacturer is going to say you need to test at multiple levels. It's going to say raise your IPAP to, say, in this case, 8 and your EPAP to 4. And what does my analyzer do? Suddenly it goes flatline. It's saying I don't see anything. And why is that? It's because we've raised our entire waveform above our trigger points. So if we've made a change to the ventilator's IPAP and EPAP value, what do we have to do to our analyzer? Change our trigger points, right? So we follow that pressure, right? If the pressure is going up, we have to raise our trigger points. If it's going down, we lower them. And we still get the entire inspiratory phase of the breath. We have accurate VTIs. So something to keep in mind if you're trying to test, you know, an IPAP or EPAP or BiPAP unit with any analyzer. Okay, so if we raise our trigger levels up, like we said, to 5 and 7, we're back to doing great. Again, measuring that whole inspiratory phase, we have accurate VTI. Questions about any of this stuff? I know we're dumping a lot of information here, but hopefully it's not. No one's fallen asleep yet. Well, maybe one guy, but a couple more quick, 2 more little trigger settings. Probably won't affect you too much, but if you do have a noisy signal, you can set a trigger delay. And what that is it's a few milliseconds of delay, and it says if you don't maintain my trigger level for longer than this delay, don't count it. Right? So if you get a little blip like we show here, this is a pretty nice clean one. It would probably just be a spike in real life. And instead of starting to say, oh, that's my next breath, the analyzer will say, it didn't maintain it for as long as my delay, so I don't count it. But once I start getting the real breath, now my pressure is above, or my flow is above my trigger setting, and I'll go ahead and count the entire breath. It's usually, I think, like 30 to 60 milliseconds that you have a chance to set that. So again, if you have a very noisy signal, really bad test lung, really bad ventilator, you can set your delay to kind of clean that up. Okay. The other thing that you might face, and I did this myself, I was trying to test a ventilator and I realized that it had base flow turned on. Base flow is a constant flow during inhalation and exhalation. And if you're trying to trigger on that signal, you don't want to count the base flow, because you'll have a bunch of volume here that you don't want, and a bunch that you don't want on exhalation either. So you can turn on base flow and match it to whatever the ventilator is putting out. Anybody tests neon codons, 360 or 330s? Not yet. They're coming out. I don't know if you've seen them yet. I was testing one. I was there at Neon Codon and using our analyzer to test one, and my tidal volumes were, VTI was way high and BT was way low, and I was like, what is going on? And it's like, do you have base flow turned on? It's like, oh, okay, no. So I have to go to my analyzer and turn on base flow. And then all of a sudden my volumes are right in there. Work great. But I started down that rabbit hole before I got to that point, going, what's going on here? Grab another analyzer and put it in place. And that analyzer said, oh, it works fine. These are perfect. And there must be something wrong with this analyzer. It's out of calibration or something like that, you know. No, it's a simple setting. So, and I thought I knew everything about that analyzer. And I thought I'd checked it. So, you know your analyzer and check your settings twice, because it happens to everyone. All right, the last thing we want to make sure, we talked a little bit about this, our measurement parameters themselves. You want to make sure that you're measuring the right thing. For example, here you have P channel, P plateau, P peak, you have PEEP. Those are all pressure readings that you might be asked to measure. They may all have different names on the ventilator. You want to make sure, again, your gas standard and gas types are set up correctly. You want to make sure that your unit of measure is set up correctly. On some analyzers, you can rearrange these in the order that you do the tests to help you. You can change their color. In some cases, you can make it, all your pressures are on a ventilator might be yellow, all the timings might be blue, things like that. You can have your parameters match what's on the ventilator color-wise. And that way there, you can see very quickly what I'm trying to measure. All right, you can reduce the number on the screen. You can make 1 or 2 parameters on the screen if you want to. You can put them in different orders. But the most important thing is to make sure they match what the ventilator is trying to put out, right? What are you trying to measure? Okay, so what kind of opportunities can we have? All these different settings that we talked about can usually be stored as a profile on most analyzers now. You can do the gas type and gas standard. You can do the trigger settings. You can set up all your measurement screens the way you want, customize them, and then you can save that as a profile so that the next time you use that or test that same ventilator, you can just pull up that profile and all your settings will be there for you. That helps minimize, again, the risk of inappropriate settings. Okay. Another opportunity is, to use these advanced aids that we have now with some of these analyzers. A lot of them are equipped with things like, on-screen waveforms. So if I'm having a trouble setting my trigger, I can actually see what the waveform is. Some of them even have graphical representations of where your current set points are. Okay. And some of the newest analyzers actually have automatic detection. So you don't have to worry about triggers at all. So something to be aware of, that those features are now available on a lot of different analyzers. And again, that just helps you make sure you have the right trigger settings. Okay, have anybody faced the kind of problems that we've been talking about so far? I know you have. Anybody else?
I kind of have an off question with.
That's fine.
3-liter syringes that we're trying to calibrate with the flow.
Yes.
We tried to do the TSI, and then didn't happen. We ended up buying, they told me a flow just for flow, but erratic results.
Really?
They weren't consistent. We were just trying to check the output of a 3 liters.
Right, so you have a 3-liter syringe sitting on the bench and you put an analyzer on the end of it and you draw 3 liters into it and then you push 3 liters out of it, right? And you want your analyzer to say on the way in it was 3 liters and on the way out it was 3 liters, and you're not getting good values?
Correct.
Okay.
Sometimes it would be okay if I just pulled it out, but going back in, it was totally.
So why do you think that is?
Well, inconsistent flow, depending on how you even push it, and then because you can push it harder, pressure,
right?
And I don't know what kind of analyzer you have that can actually get consistency, because when I saw that for volume and fuse,
yes,
that was right on.
Yeah, so
3 liters.
Come by the booth later and I'll show you how to do this. But for everybody, I've done this myself, and it is somewhat technique dependent, because what you're trying to do is create that inspiratory phase, right? And so, and have it end, and it does as you push this in, right? But if you push it in too slow, the ramp is really flat. And so by the time you hit your trigger point to trigger your analyzer, say start counting that volume, you've already lost a big chunk of the volume, right? It just went out, it wasn't even measured. So again, the best thing to do is set your analyzer up so you can see the waveform as you do it, and then you can set your trigger levels at the right places, and you can just go back and forth all day long, and you can see, oh, well, that was a good one because I saw the waveform. It was steep on both ends. It wasn't really slow, really rounded, or it wasn't too sharp. And that way your technique will be better. Okay, and then if you have appropriate trigger settings, you should be able to get nice clean volumes.
I even called the company, I think it, I
Really?
don't remember what brand we bought.
Yeah.
I even called them for tech support. We're trying to like, he was trying to walk me through the settings too.
Ah.
So, maybe yours is better. Come by your booth.
Exactly. Yeah, and I don't know if ours is better, but I can show you how I would test it. I've done those before.
The catch with doing one of those is when you have the 3-liter syringe,
Mhm.
it also is sensitive with the heat of your hand. When you're doing your syringe
Yeah.
testing and whatnot, and you do get frustrated if you're having issues with it.
Because you're holding it with
for
one.
so long. And
You're actually changing.
your resistance of your hand and your heat, you are putting that into there, and that seal, you are getting,
Yeah.
you know, there is studies of that.
Oh, I didn't.
There's actually a paper out there on that. And it's, if you're getting, maybe there's a geek in me, but.
No, that's.
But it's, yeah, that's another rabbit hole. You know,
It's okay.
it's, I know what you're talking
It's so
about.
variable. I
It's
mean,
tough.
Yeah,
yeah.
it is.
different people,
It's a tough thing.
Yeah.
really-
Yeah, you think, oh, if I just push this and
Yeah.
pull it, it should just be the same, but that waveform, if you have a device that displays the waveform for you, then you can see if it's a good one or a bad one.
Okay.
And then you can measure it at the same time.
Yeah.
And you can see what are my tidal volumes. And you can put all three of those on the screen and sit there and do it all day long and practice it.
Yeah, go talk
Yeah.
to the PFT person.
Yeah.
I know.
They have to do it every single day anyway. So,
Yep.
yeah, you have to watch a circle.
know,
They have to
the
move
circle.
Okay, I'm getting a little long here, but we'll cover this pretty quickly. And this is the challenge that this is frustrating sometimes. You'll see that you'll have here's an example from an analyzer or a ventilator manufacturer, and it says we're going to test at 0, 10, 35, and was that 60, right? But then it gives you this long equation on what is the actual value, right? It's insane, and yeah, and
Yeah.
then it says it was so messed up that they actually give you examples of how to get this, and it's just like, wow, I actually tried this, and it took me 9 steps for each level of measurement to do the calculation, right? It's just like, so I mean, you know, you have to read the pressure and the analyzer, and then you have to judge, you know, is it correct or not? I mean, you go through all these steps, and that's just at 0. Now you have to do it for all the others. So we are challenged by these kind of setups and these test requirements. You know, who came up with that? Probably the engineer that helped design the ventilator. And, you know, they did that for validation, and they just threw it in the manual because that if it works in the lab, it should work out in the field, right? Another example, again, you know, they have this, it's kind of hard to see, sorry, it's kind of a little small, but my reading is A, which is the value that I have set, plus minus 0.5 times a plus 15% times 1,000 milliliters. Again, I lined it all out, and this time it was about six different steps for each data point that I want to collect. And all I can say for these things are, look for units that now have guided test apps or test sequences available that you can write, okay? So you can actually go through one of these tests, calculate all the values that should be available to you, save them, and then rerun them each time you do this. And if you happen to have a device that has the app for that particular ventilator, all that is done for you in the background. So some of the new analyzers are really good. The state-of-the-art ones have ventilator-specific apps, and they actually guide you through testing. They show you graphically how to do test setups. They show you what ventilator settings to make, and then they actually have the pass-fail criteria built in and will capture the data, give you pass-fail, and at the end of it, it will actually create a report for you.
Do you do updates on that? When new devices come on the market, you release new?
We try to. In our particular case, yeah, the apps that we're building in our library, we're trying to develop them with the manufacturers if we can. If we can't, then we'll do them on our own. And anytime that we release them, all you have to do is update your software. Sorry, I'm not supposed to do a sales pitch here, but that's the way ours works. Others may as well. But yeah, ours come, you get software updates anytime you want for free. Check them often. If we have anything new released, including new apps, it's included. Okay. So again, helps you with your workflows, makes it more expedient. You don't have to do all the calculations yourself, and helps eliminate a lot of errors. Key takeaways, we'll wrap this up. Ensure that you know your analyzer. If you don't, spend some time with it, try it out, talk to other people, see how they've done things, really kind of dive into it and get to know it. Pay attention how the setups are. A lot of times manufacturer will say or equivalent. They may have gone a long ways down the road showing you one analyzer, but you can do or equivalent, and then it's up to you to figure out how to do it with that analyzer. And then take advantage of all these new features from the new analyzers. It's getting so nice. If you can see graphics on the screen and the number of parameters, numerics, you can go a long ways, getting things dialed in. So they should help you with some of these problems. Come to our booth. This is my pitch right here. Come to the booth. We're at 3:30. You can take a look at our analyzers and play with them, and ask questions. We can try them out. And thank you. Any questions? I still have. Oh no, it's Friday at 9 o'clock. Bang.